In this section, we will also talk about systems of equations, except we will talk about systems of non-linear equations. In the previous section, you may have noticed that we only had equations of this form. We only had equations of the form ax plus by equals to c, where this was a linear equation, meaning that the degrees of each x and y were both degree 1. However, in 7.3, we will talk about systems of non-linear equations where we have some squares as well. Okay, so first one, it says, find all the solutions of the system using elimination. So for elimination, we have to choose a variable. And this time I'm going to choose the y's because it's going to be a little bit easier. So the reason I choose the y's is because if you notice, we already have one positive and one negative, and the coefficient is the same. You have a positive one and a negative one. So if I just add these down, I have x squared and x squared. That gives me a 2x squared. A plus y squared and a minus y squared, those are already additive inverses. So they just add to 0. They cancel. And then I get 5 plus 3 is equal to 8. Now, when I solve this, I need to get the x squared by itself. So I do that by dividing by 2. And I get x squared equals to 4. And the inverse of a square is a square root. So I am going to square root the left side and square root the right side. So what am I left with? I'm left with x on the left. And remember, whenever you square root a variable, we get a plus or minus. So I get x equals to plus or minus 2. Now, this is a little bit different than last section because in the previous section, we only got one answer for x. Here, we got two different answers. We got a positive and a negative 2. And remember that anytime you square root a variable, you always get that plus or minus. So if I have x squared equals to a, then x will always equal to plus or minus the square root of a. That plus or minus is always going to be there. Okay, so don't forget that. All right, now I'm going to have two different cases. Case 1, x equals to 2. Case 2, x equals to negative 2. And I have to solve for y in each case. So let's start with the first case where x equals to 2. And it doesn't matter which equation I use. I'm going to use the first equation. My first equation is x squared plus y squared equals to 5. And x is 2, so I'm going to have 2 squared plus y squared equals to 5. 2 squared is 4. So I get 4 plus y squared equal to 5. I move the 4 to the right. So I get y squared equals to 1. And now I have a square. To undo the square, I'm going to have square root both sides. So again, by this property here, I'm going to get y equals to plus or minus, radical 1 is 1, so I get plus or minus 1. So when x equals to 2, my solutions are y equals to 1 and negative 1. So here's how I'm going to write those. I have 2 comma positive 1, and I have 2 comma negative 1. So those are two of my solutions. In the second case, x equals to negative 2. So once again, I can use either equation. I'm going to use the first one again, which is x squared plus y squared equals to 5. Now this time, x is equal to negative 2. So instead of saying x squared, I'm going to say negative 2 squared plus y squared equals to 5. So negative 2 squared is 4. I get 4 plus y squared equal to 5. I move the 4 to the right, and I get y squared equals to 1. Once again, if I square root both sides, I end up with y equals to plus or minus 1. So I get the same y values, but this time the x value is negative 2, not positive 2. So now I have negative 2 comma 1, and I have negative 2 comma negative 1, because the x value is negative 2 with the y value of positive 1 and a y value of negative 1. So I have 4 different solutions. My solutions are going to be 2, 1, 2, negative 1, negative 2, 1, and negative 2, negative 1. So for this section, make sure you set it up kind of like this, where once you get two values of x, take each separate case and solve for y for each of the separate cases. Let's take a look at our next example. We have x squared minus 2y equals to 19 and x squared plus 5y equals to 40. Notice that here we have x squared and y squared. So because they were both degree 2, we got 4 solutions. Here we have one x squared, that's a degree 2, and we have a y, that's a degree 1. So we should get 3 solutions here. Okay, but let's use Let's use our elimination. You can choose any variable. You can pick the x squared. You can pick the y. It doesn't matter. I'm just going to go with the y's once again to keep things kind of consistent. So to eliminate, I always take the equation, and I'm looking at the y's now, and I multiply that by the opposite coefficient. So I'm going to multiply this one by 5, and I'm going to multiply this one by 2. Now the question is, do I need a negative? So to answer that question, I look at the signs. If they're the same, then I need a negative to change one of the signs. But if they're already different, if I already have a negative and a positive, then I don't need one of these to be negatives. So I'm just going to multiply by a 5 and a 2. It's kind of like finding a common denominator. I want to make them both into a 10. Now, let's see what happens if I distribute this. If I distribute this, I get 5 times x squared, which is 5x squared. 5 times negative 2y, that's a negative 10y. And 5 times 19, that's a 95. Over here, I get 2 times x squared, which is 2x squared, 2 times 5y, which is a 10y, and 2 times 40, which is an 80. So 5 and 2, that's a 7x squared, negative 10 and positive 10, that's a 0, and 95 plus 80, that's going to give me 175. Now, in order to solve for the x squared, I take the 175 and I divide that by 7. So if I divide both sides by 7, I'm going to get x squared equals to 25. Okay, and then finally, to get the x by itself, I'm going to square root both sides. The inverse of a square is a square root. So I square root the left, square root the right. And what do I get? I get x equals to plus or minus 5. And remember, every time I square root a variable, I always get that plus or minus. So now I have two different cases, x equals to positive 5, x equal to negative 5. To get the y value, I can use either equation. Let's say I go with the first one, which is x squared minus 2y equals to 19. I know that x is 5, so I'm going to get 5 squared minus 2y equals to 19. This is 25 minus 2y equals to 19. I subtract 25 from both sides. This gives me negative 2y equals to negative 6. Divide by negative 2, I get y equals to 3. So when x equals to 5, y equals to 3. Now what about when x equals to negative 5? So again, I can use either equation. I'm going to use the first one. I have x squared minus 2y equal to 19. My x is now negative 5, so I get negative 5 squared minus 2y equals to 19. So this gives me 25 minus 2y equals to 19. I move the 25 to the right, so I get negative 2y equals to negative 6. Divide by negative 2, and I get y equals to positive 3. Oops. So my second solution is going to be x equal x, this time x is negative 5 and y is positive 3. And these will be my two solutions. And earlier I misspoke. I said we should get 3, but actually we should get 2 solutions because the highest degree is a 2, so we're going to get 2 different solutions. All right. The next one we will do in class. Now the next one, this time we're going to solve this using substitution. So substitution, the steps are 1, get a variable by itself. So we already have the y by itself, so we can use that. Now here's what we're going to do. We're going to take the value of y, which is 5x plus 2. Not the value, the expression for y, which is 5x plus 2. We take the expression for y, 5x plus 2, and we're going to substitute that entire expression in that second equation. So instead of y, I'm going to replace the y with its equivalent, which is 5x plus 2. So I'm going to get 5x plus 2 equals to negative x squared plus 2. When I have a quadratic equation, I need to move all terms to one side. And I want to keep the x squared positive. So what I'm going to do is, instead of moving everything to the right, because I want to make the x squared positive, I'm going to add the x squared, and I'm going to subtract the 2. So same thing over on this side. I'm going to add the x squared, and I'm going to subtract the 2. So what happens when I do that? So when I do that, the x squared and 5x, those are not like terms, so I have to leave those separate. I have to have x squared plus 5x, and then the 2 minus 2 is going to be 0. So I get x squared plus 5x, equals to 0. Then I have to factor out a variable. So when I factor, they both have a common factor of x. So if I factor that out, I'm going to get x times x plus 5 equals to 0. Remember that when I factor, what I'm doing is my GCF, my greatest common factor, I'm dividing each of these terms by x. And that GCF goes on the outside, it doesn't just disappear, but x squared over x is x, 5x over x is 5, so we get x times x plus 5 equal to 0. And now by the zero product property, if two terms multiply to be 0, then either x has to be 0, or x plus 5 has to be 0, or they both have to be 0. So we're going to get x equal to 0, or x equals to negative 5. So we have two different values of x. I still want to find a value for y. So I'm going to set up my two different scenarios. My first scenario is x equal to 0. My second scenario is x equal to negative 5. If x equals to 0, then I'm going to get y equals to 5 times 0 plus 2. 5 times 0 is 0, so I get y equals to 0 plus 2, which is just equal to 2. If x equals to negative 5, I'm going to get y equals to 5 times negative 5 plus 2, and I'm using that first equation, 5x plus 2. So I replace the x with 0, then I replace the x with negative 5. So this gives me y equals to negative 25 plus 2, which is going to be negative 23. So my solutions are going to be 0, 2. If x is 0, then y is 2. My second solution is going to be if x is negative 5, then the value of y is negative 23, and that'll be my solution set. So quadratic equation, get everything to one side, and then factor, and then solve. If it's not factorable, use a quadratic formula. Okay, last problem. We're gonna do this one in class, but I'm gonna start the setup here. A rectangle has an area of 252 square centimeters and a perimeter of 64. What are its dimensions? So we have a rectangle. Now, just a couple of formulas. The area of a rectangle is given by length times width, and the perimeter of a rectangle is given by 2L plus 2W, 2 times the length plus 2 times the width. What are its dimensions? So we don't know what the length is. So I'm going to call the length L, and I'm going to call the width W. Now, the area is 252, and the formula for area is length times width. So length times width, that's going to be 252. That's the area. So the area is length times width, and that equals to 252. The perimeter is 64. So how do we get the perimeter? It's 2L. So we got 2 times L plus 2 times W. That's equal to the perimeter, which we know is 64. And before we start, I'm going to simplify the second equation a little bit. Notice that they all have a common factor of 2. And anytime all the terms of an equation have a common factor, I highly recommend you divide that by that common factor to make things a little bit easier. So here's what we get. Our first equation is going to be the length times the width equals to 64. And our second equation, 2L divided by 2 is L, 2W divided by 2 is W, and that equals to 32. And these are our two equations. And in class, we will talk about the best way to solve these. So we'll finish this up in class.